For today's webinar, we have Doug White, a criminal computer scientist at NIST, presenting digital caseload processing with the NIST National Software Reference Library. Without further delay, here's Doug.
Hello, I'm Doug White with NIST. I am the project lead for the National Software Reference Library, and I'm pleased to be able to discuss with you today digital caseload processing with the NIST NSRL. Just to start with our regular disclaimer, any products, equipment, instruments, etc. that I mention in this presentation does not imply recommendation or endorsement. So what is the National Software Reference Library? I'll start out with a pretty high-level description. We're supported by federal, state, and local law enforcement to promote effective and efficient use of computer technology in investigations of crimes involving computers. So what this means is we collect software from many sources and compute metadata profiles into a reference data set. You'll hear me call it an RDS. That's used by law enforcement, government, industry organizations to review unknown files by matching those profiles. That automates much of the effort in determining what files are important as evidence or what files can be filtered out of a case. The RDS core is a collection of digital signatures or hashes of known traceable software applications. There are apps in the collection that may be considered malicious. There are no hash values of illicit data, so we are not a pure innocence filter. You can also use the reference data set metadata to look for malicious or notable things. The graph on the right-hand side there shows that we ingest physical purchases, download-only distributions. We publish the NSRL reference set, the RDS. We also collect metadata from virtual machine installations, and we have some other research corpuses available to people. So what do we collect? We collect free software, and we purchase software through public commercial channels, anything that someone would get commercially off the shelf. And some vendors do provide and allow NSRL to use unlimited licenses. The majority of the software is for microcomputers that run Windows, Mac OS, or Linux, and mobile devices that run iOS or Android. We acquire the titles by popularity. Titles are apps that are most likely to appear during investigations. We have a steering committee that's comprised of representatives from NIJ, from other federal law enforcement agencies, from state and local law enforcement agencies. They identify software that the NSRL should acquire, and that could be key logging software, that could be communication software, software by language or by particular manufacturers. And you'll see some examples later of those. Notable items in the collection other than standalone software are mobile phone images, online game platform titles, and live system snapshots of updates. So just a quick graph, in the middle of 2009, we had about 500 million files collected in the database and being able to be published. Just recently, we went over 1 billion files in the collection. Now we're up to almost a billion and a quarter at the time of recording. So we have a very good growth curve. How do people obtain the NSRL data? It's freely available for download, and our URL is here on the slide, www.nsrl.nist.gov. Through December 2022, we have been distributing what we call version 2.x, where customers downloaded large ISO files every 3 months. We are switching over to RDS version 3, which is a SQLite database. It's going to be one large file as a one-time download, and then rather smaller updates that should be much more easier for people to accommodate into their setups. Just as a quick look at the download examples, that first one-time large file is going to be about a 60 gig, 70 gig download, a zip file. It extracts into a 230, 250 gig database file. So that's a one-time download. And then those are tagged by the year and month and then release. So RDS 2022.03.1. That was the March #1 release for that month. RDS 2022.09.1, that's the September update release, a Delta release. That's a smaller zip file, about 3 gigs, and it has about a 16 gig update script in it. So that's what a monthly update would be, just a simple script that gets applied to the current database. We also have targeted reference data sets. So we publish 4 different sets every quarter. One that targets modern PC software from 2010 to the present. One that targets PC software from 2009 and earlier. One specifically for Android, one specifically for iOS. So right out of the gate, those sets can be useful in speeding up case processing rather than importing and searching through the entire collection. If you know you're just going to be handling only iOS devices for a certain set of cases, you can just link to or use the iOS set. How's the metadata used? The most common use of the NSRL RDS metadata comes from importing the data into a commercial digital forensics tool. Our data is just data. It's not a tool by itself. So a tool would provide user interface to automate the comparison of file signatures or the hashes and filter the files that are under investigation into sets. Here in the top colored block, you can see a highlight of a hash of a file called VB5DB, a Visual Basic DLL file. That's the signature that we have computed for a particular instance of that file. On a device, when the hashes are calculated, you can see in the lower block that same VB5DB.dll file has a very much different hash value. So instead of starting E6B, it starts out 14F. That is just an example of how behind the scenes the automated tools are comparing the hashes, and they would flag that as something different, something unexpected. It's fairly easy to create just a list of hash values from these sets. This is a quick command line example. Using a SQLite 3 command line tool, first thing you do is you would check the version of the database that you're using. That's the first command there. And that tells me I'm using the 2022.09.1, the iOS set, and that in the description, this is actually a demo for presentation. So this is not the full complete set. It would say full set if it was from the distribution, and it would have some signatures with it. The second command there says select distinct SHA-1 from metadata. That's a simple command. You can also do MD5, select distinct MD5, or select distinct SHA-256, and output that into the file of your choosing. I chose RDS demo SHA-1.txt. And then after that was done, that takes less than a minute. I just displayed the start of that text file just to show that, yes, it is the specific SHA-1s. So it's very much easier than dealing with the old RDS2 set, where you had to use various other tools to parse the data and then present out the hashes that you wanted. So advanced investigations, some of the things that you can do now, if you have access to the database, if you are a frontline investigator, you might just be using that tool. The tool might actually have some of these possibilities built into it. We have been working for the last year with vendors on incorporating the RDS version 3 data into tools. So some of this might be available in tools. If it's not, this is some things that you can do yourself if you have access to the database to help along in investigations, or get in touch with your tool vendors and let them know that this is possible with the metadata now, and see if they can build anything into their tool to accommodate this. So one of the things we can do is actually identify the titles of possible software. So let's say you're investigating an iOS device and you find there's a file called usapolicesiren.wave. Why would someone have a audio file of a police siren on an iOS device? Don't know, but it might be useful to know that a file from an app called 50 Radio Pro Police Scanner is that particular file, and that was found on the device. Interesting that someone has an iOS device with a police scanner on it. So what you can do with a browser or in the command line, I'm using a browser right now just to show you visually some of the searches that go on. In here, given that you like to report the app name, the app version, and who manufactured the particular app, you can actually drop that file name, USA Police Siren, and you can see that about in the middle of the screen in red. You can drop that into a query into the database. Or hopefully a tool vendor would write a wrapper around a query like this to let you just drop a file name in. And so it took about 5 seconds to find out that, the only apps that use a file called USA Police Siren are the 50 Radio Police Scanner, the Pro version of that, and then another scanner called Police Scanner Plus. So that could be interesting. If you find a file with a name such as, dirty bomb launcher, or, some sort of keyword that your case depends on, you could drop that in here and see, what app could that have come from. Another thing it can do is identify possible operating systems. It might be of interest to know if a computer or device has hosted multiple operating systems, such as a virtual machine container or a different disk image from another type of operating system. So once all of the systems files have been hashed, it's possible to run those hashes through a database query through a filter of the RDS and actually find out that this was a Windows 10 machine that you imaged, that you captured, but why does this person have several versions of Linux apps on it, within this particular virtual machine? They claim not to be technically competent for that kind of thing, but here it is. This is what's been found. So that might be interesting. I don't have a good example of showing this because that's tricky to dump a large set of hashes into a query, but it can be done. Also, to identify versions of software. Let's say that several Android Signal Messenger files are found. To which versions of the software do they correspond? So you might, in query, looking through the device, if you do a logical image and are able to, look at some of the files and file names on the device, you might find something called emoji_data.json or camera-view.version. You could actually do a query and see what version of Signal theirs might be from, or what version of any app theirs might be from. And in this case, again, a quick example here, we've dropped the file names into a query, and we find out that these only come from Signal version 5.24.7.1. That could be of interest. Is that the most recent or a very recent version of Signal, proving that they're keeping this device up to date? Or, is it a very outdated version, proving that, it hasn't been connected to the internet, hasn't been updated? We're just giving the information so that you have the background for your case. Another advanced investigation could be create a data subset for notable software. So the application type, manufacturer, or operating system metadata could be used to build sets of classes of software. So this does not determine if a class is notable. Investigators may customize a set for their needs. So one example that we actually built recently was a set that described Kaspersky products that run on Windows 10 Enterprise. That was for a government-wide effort to try and identify where those files are on any machines. So here's a quick look at, again, in the iOS database, we have an application type table that anyone can look at. There's about 50 different types of application categories there. That's the description column. So you can see it's generally categorized as, weather apps, travel apps, social networking apps, shopping apps. So if you've got a particular need, let's say looking for social networking, some of the dating apps, does anybody use the meetup apps, possibly that relate to the case you're working on? You can actually build a filter that only queries the social networking type apps. Another example here is rather than just trying to do a query one time, since it's a database, you can create a temporary view or a new table that actually captures the notable items that you're interested in. You can build one that's temporary just for a one-time use, or you can actually build these views that won't interfere with the regular use of the database to stay within the database. So in this case, all the way down on the lower right, you can see we wanted to build something where description is like finance. So if it's a financial fraud case, you might want to have all of the metadata of all of the apps that relate to finance in a particular smaller table that would make it faster to actually perform the queries and do the filtering on those things. So that's where NIST doesn't classify things as malicious or innocent. Financial fraud is a good example. You can also use for the PC software, there's about 500 different categories. So you can pull out such things as keyloggers, such things as steganography apps. It's really down to the investigator or the particular caseload person to if you really want to focus the filter on what could be malicious or notable items, you can go through that application type table and identify what is important to the particular case for you at the time, and create, like I say, either a permanent view in the database so that everybody who works on financial cases, financial fraud cases, could reference that at any time. What's nice about a view is it also gets updated automatically when the database itself gets updated. Since the view is based on just a SQL query, it will always be fresh with the latest release. So again, a couple of things to review here. How to check the release version. That was in a slide earlier. You can either browse the version table in a GUI tool, like is shown here at the bottom. Go to the version, and it tells me, what it is. It's the 06, the June release for iOS, and it's the NSRL generated Delta build. Or you can run a command line SQLite 3, the name of your database, select star from version command, and that would give you basically a one-line response on the command line. So RDS2 versus RDS3. Like I said, it's been a year now. RDS3 has been out. We know that there are tool vendors that are building to it. We've had some questions back and clarified some things, so we know that it is out there in the field, so to speak. New data that's in RDS3 that has not been in RDS2 includes SHA-256 hashes, the full product versioning information. Just due to the way that RDS2 was distributed, it wasn't a complete versioning set of metadata. Now that's available for more precision, and if especially on the mobile things, if there's a particular tool now that can carve a SQLite database behind an app that is, let's say version 15 or less. Then if you find version 14 on that phone or on that device, you might be able to use the particular tool to do that. Additional manufacturer information is in RDS-v3, original string encodings. So if now there's an app or a file that has an emoji in the name, or a different language encoding, that's available to be decoded and reviewed in the new database, in the new SQLite version 3 database. File location data within a software package. So if you have access to a logical image of a device, and you can see that it is there is an interesting artifact in a folder tree or in a particular zip file or jar file, etc., some sort of container, we're providing you the information that would show that we have tracked it down into those locations. The RDS version 3 schema also includes file, manufacturer, operating system, and package table views. So it's backwards compatible with RDS2. If you need to have the RDS version 2 text files, those 4 views allow you to actually generate those version 2 files and import those into tools that aren't yet supporting RDS3. So we try to make it as backward compatible, as easy to run with as possible. Just another quick review. How do you apply different RDS-v3 publications? There are SQLite 3 command line tools. There's SQLite viewer desktop applications, or in association with your computer forensics tools. And if there are tools that you're finding don't support RDS3, please drop us a line. Let us know. Our project email is nsrl@nist.gov. Let us know, and we're happy to work with vendors to try and get that metadata into the tools as easy and as comprehensively as possible. Also, this makes it easier for you to check the version of the database of the RDS release within those tools. I know sometimes a tool will come with NIST metadata preloaded and no instructions or lacking instructions about how to update that. So we've been contacted by some people who, say my tool doesn't find any Windows 11 files. Well, that's because the metadata in it has never been updated, over the past few years. So how is the RDS-v3 database updated? With a Delta publication, fairly easily. If you have that full copy of the RDS release, download the Delta publication. Like I say, that's a 2 or 3 gig file. From the command line, you do 2 quick commands, SQLite 3, and then the name of the database you want to open, and then a simple command .read, and then the name of the Delta file that you want to apply. That's it. Takes a few quick minutes, and it will insert all of the new metadata that we're distributing at that point in time, and also update the version in the database itself. So that's why we always say, query the version before you use it. Verify that it's been updated or is the version you expect. From a SQLite desktop application, same thing. Open the database and do that read of the file, and boom, it's updated. So a lot more simple than the old replace the whole ISO version. Again, thank you very much. I hope this has been a worthwhile presentation for you. If you are a frontline investigator who doesn't have access to the database or some of these tools, please let whoever is managing the hash set for you know that these capabilities are possible there. Again, let us know if your tool doesn't support it. We're willing to work with the vendors from our side. Also, We love to have suggestions. If you think we are missing any particular types of applications, let us know. When Windows 12 comes out, we'll be on top of that. But if we aren't, give us a holler. Anything else, we're here. And also, NIST has other digital forensics projects. There's a URL at the center of the slides, nist.gov/forensic-science. Please take a look at that if you're interested in any further digital forensics information. Thank you very much.
Alrighty, thank you very much, Doug, for that great presentation. We're going to go ahead and jump right into our Q&A now. Our first question is, does this mean I need to learn SQL to use the NSRL?
No, quite simply, we did not want that to happen. We tried to make it as simple as possible. If you are the person who is managing the database, it really is one quick command to do the updates, one quick command to dump out the data in the old style, in the RDS2 style. And in our FAQ section up on the website, we're going to be posting scripts as we hear back from the community. Anything that someone asks us they might need, everybody might need it. So we're gonna follow up with that in the FAQ section.
Gotcha, that's great. Trying to make it as user-friendly as possible, it sounds like. I have another question here for you. If I make special copies of the NSRL, do I have to update all of them for each release?
That's a good question. If you are just using the database as it's distributed, that one update should handle everything. Like I mentioned with the one slide, if you choose to make views, there's new temporary tables inside the database. Those automatically get updated whenever a regular update is applied. If you take data out of the database to make a special set, if you run one of our SQL scripts to make a special set for yourself, then yes, once the update is applied to the database, you would just have to rerun that script again. So again, trying to make it as simple as possible.
Gotcha, that's helpful. Thank you for your answer there. All right, moving on to the next one. Can you provide an example of a case when a special set has helped an investigator?
Probably our best known and publicly known example of that would be when the Malaysia airliner went down in the Pacific or Indian Ocean. The FBI is one of the agencies on our steering committee. They contacted us. They let us know that they were going to be getting a copy of the hard drive from the pilot's home computer where he practiced flights before crashing the airliner. And with a little bit of notice, we were able to specifically buy the versions of the software, all of the international maps, all of the support files, etc., for that particular piece of software, and hash everything and get a hash set and metadata set specifically for flight simulation and that particular title to the FBI, so that they could of the tens, hundreds of thousands of files that deal with map data and the simulation data, they were able to filter that out of the way and specifically focus on the data point database in that software that showed, where he was practicing the flight. So that's probably the highest and, like I say, most publicly known, so I can talk about it, example of a case with a special hash set.
So yeah, that's awesome. Question from me here. What about a, what's a maybe common or more day-to-day example of use of the library?
Day-to-day, I mean, we hear back from several people. Occasionally we get, thank yous that using the filter makes investigations go much quicker. People usually, I think, because they're not aware of some of the subtleties in the data, basically throw the whole set at a case, which is not a bad thing. You know, you're covering everything. So I don't think people are very aware that you can tweak it very well. So like I know that some tool vendors had come out with what they call notable hash sets, having to deal with very particular types of applications. We're able to mimic that now since we have the application type descriptions. Anybody who wants to build something, I always go back to the fact that we can't call what's good or bad, with the example of a financial fraud case. Tax software and checkbook software and those types of pieces of software aren't malicious. Most people have them these days for online banking, etc. But when someone has 4 copies of the books on their computer in different pieces of software, that might be a red flag to someone in a financial fraud case. That's the person who's there working the case, that's their call.
Gotcha. Yeah. Thank you for those examples. No more questions coming in at the moment, but if any do come in, we will ask them. But I think you mentioned you wanted to do a short demo.
Sure. Yeah. If I can share screen, let me turn on my desktop. Okay. You should be seeing a desktop with a command line window. Just as a quick example, I list a couple of the databases that actually are over on the left-hand side of the screen. And again, that example of doing a query on the iOS database, tell me everything about the version, and it shows me it is the demo for presentations. But I'm going to open up our modern PC database, and this is the live one, the actual real one. This is a GUI that I'm familiar with because it runs on Linux, Mac, and Windows the same way. I'm going to browse to version first, and it tells me, yes, this is the September release of the modern set, and it is the full RDS database build. So I know we're good to go with this. And I'm going to look at the application types, since we're talking about those. And you can see down here at the bottom of the columns, it's showing, the first 28 of 513 different application types. So this is where you could pick and choose to build a specific kind of set. If I look for things that are, if I can spell crypt right, CRYPT, there are cryptography, there are encryptions, and there's even cryptocurrency. So again, that might be something that would be of interest. Is there a cryptocurrency managing piece of software, on this device? Quick overlook of the database structure. Application has information about the particular apps, the package ID name, the version that it is, builds, copyright dates, etc. You can sort by the various languages. If you know that you're specifically looking for all of the Russian software that we know of in the collection, like I say, like the Kaspersky software, you can search for that by operating system. And let me just go over to the operating system. So we've got 954 different operating systems you can pick from. Generically, there's a lot of Windows, but you can see some old AIX, some IRIX, some of the old MS-DOS, various different versions of Linux types of operating systems. If you don't need those, you could filter those out. So of the billion files that are in the database, you might not need 25, 50 million that deal with PC2, those old operating systems. Trying to think if there's anything else. If you just take a quick look at some of the applications. So, you could search by name here on, let's search what, we've got all kinds of torrent related software here, 66 different versions of qBittorrent and uTorrent, etc. So a browser like this might give an investigator insights into the different filters that could be built. I'll stop sharing for now and see if that piqued anybody's interest with questions.
I don't see anything else coming in, but that was a pretty helpful example there you showed. It seems like a very powerful resource that's available. If you have any final thoughts you want to share with the audience or anything else, you can feel free to mention those now.
Sure. Yeah, we're available. Happy to help. If anybody's got particular questions, behind how to use the database, or dive deeper into some of the sections of data, please get in touch with us. Our team's email is nsrl@nist.gov. We're happy to work with you. Happy to work with tool vendors. If there's a particular tool you're using that doesn't seem to take advantage of the capabilities, let us know. We'll work on it from our side. And again, the shopping list. If there's any apps that you're coming across that we don't represent in the set, let us know. Your tax dollars at work, we'll get them and feed them back into the set.
That's great. All righty, Doug, thank you so much for your time today. I'm going to go ahead and put your contact information back up on the screen. And if anybody has any questions, feel free to reach out to that email. We really appreciate your time. Before you leave today's webinar, please participate in our short 5-minute survey. Simply click the checkbox icon directly above the chat to access the audience feedback survey for today's event. Your feedback is critical information that helps us improve our webinars and continue providing the best experience possible. We would greatly appreciate it. Lastly, across the top of the live stream window are links to our social media profiles, including Twitter, LinkedIn, and Facebook. There is also a link to the FDCOE website, the Just Science podcast, and the FDCOE newsletter registration. Like, follow, or subscribe to stay up to date with everything the FDCOE is doing in support of the forensic community. Thank you again for attending, and we hope everyone has a great day.